Okay, everyone, welcome. It's time for today's the latest CPM webinar, soybean prep optimization. I'm your moderator today. My name is Ryan Dietzenbach. I'm the Global Sales Director for CPM Industrial Solutions for the oilseed industry. Today's presenter is Ian Hall. He's our Technical Sales Manager, also globally for the oilseed industry. Ian has been with CPM for over 8 years and has quickly become a worldwide and recognized expert in the industry. Little housekeeping, if you would. Please use the chat function to post questions. Feel free to anytime during the webinar to post a question, and then when we get to our Q&A at the end, we will go over those questions and answer them the best we can. Encourage the questions for sure, but also after the webinar, for one, this will be recorded. You'll all get a link to download a copy of the presentation to share within your businesses. And also, if there's questions afterward that are generated, please reach out to Ian and our team, and we're happy to answer those for you. So without further ado, we'll get started. Ian, it's all yours.
Thank you, Ryan. Okay, everyone, good morning, good afternoon. This is the soybean prep optimization. We're going to be going over all of the CPM equipment that you would see in a soybean prep building and how to optimize that. Before we get started, I always like this slide. We always recommend that anytime maintenance personnel or operator or whoever loosens a bolt or takes a guard off, that they lock and tag out the machine. These machines are very unforgiving. We don't want you guys to get hurt, so make sure you follow your lockout tagout procedure. Okay, starting off in the prep building, the first CPM equipment that sees the soybean is the cracking mill. So today, for optimizing cracking mills, we're going to go over proper feeding, splitting the work between the top and bottom sets of rolls, roll corrugations, teeth per inch or grooves per inch, parallel and tram of the rolls, and then roll speed differential. When we talk about proper feeding, typically your guys' CPM cracking mills will have a high volume pocket feeder on the top of the machine here. You see that we have 3 magnets to prevent any ferrous material from dropping through the rolls. The high volume pocket feeder, that is volumetric, so you guys can measure how much capacity you're putting through each line of dehulling or your cracking mill. We do want to make sure that we get a feed full width all the way across this pocket feeder here. Okay, if you can imagine your transition coming down on top of your cracking mill, we want to make sure, if you have a 16 by 84 inch mill, that you have a full 84 inch width curtain dropping through the sets of rolls. This will allow for even roll corrugation, or sorry, even roll wear, and it will allow for you know, a more consistent size coming out of the machine. Okay, when we talk about splitting the work up between the top and bottom pair, okay, I get a lot of confusion out in the field on this. Okay, everywhere I've been, typically soybeans are not the same size. Okay, and when they're feeding through, what I see is a lot of people are just using the top set of rolls or the bottom set of rolls at one time. We have a single motor drive here, so we want to make sure we're utilizing our horsepower to the fullest capabilities. So what we do here is we want to split up the beans cracking through this machine through the top and bottom pair. And when you have soybeans that are uneven in size, let's say, the bottom set of rolls should be picking up those beans. All right. If you're in a hot dehulling situation or a warm dehulling situation where you have dual cracking, okay, on your first stage of cracking, we just want to see halves coming out of the bottom here. All right, but we don't want all the beans getting split into halves on the top set. Okay, this is going to unevenly wear these rolls from the top set to the bottom set. Okay, so what we want to do is we get, you know, let's say 50–60% of the beans get split into halves. You might see, if you use your sample scoop through here, you might see some small beans that haven't been processed. That's what this bottom set of rolls are for. Okay, if you notice that you're getting more wear on the top side than the bottom side, go ahead and push in your bottom set of rolls in a little further. Okay, again, this is going to allow us to utilize our horsepower to the fullest. We're also going to wear our rolls out evenly, so when we do a roll change, we can take all 4 rolls out and put 4 new rolls in. Okay, roll corrugations. These are the top 3 that I see typically out in the field. You have sawtooth, which has been around for forever. You also have round bottom V, and then the Bueller cut, or the B&W cut, as we would call it. What I typically like to see on, let's just say, the first stage of dehulling or cracking, I like to see the round bottom V on the top set of rolls. It's our opinion here at CPM that the round bottom V does a better job of accepting those round beans. Round beans are notorious for bouncing, and every time a bean bounces, it's going to wear something out. So I like RBV on the top set of rolls here, and then typically on the bottom set, I like to go with the B&W cut. It could be sawtooth if that's what you guys are used to. And again, this is just our opinion here, but you know, I do see where people have sawtooth on the top and bottom, or B&W on the top and bottom as well. It works great, but if you guys have an issue with beans bouncing on the top set of rolls, try to switch out to this round bottom V here and see if that helps you out a little bit. Okay, we also have grooves per inch here. It's exactly what we mean. This is the top set here is 3.5 grooves per inch. And that's exactly what it is, just 3.5 grooves per 1 inch. And then down here, we're seeing a 5 grooves an inch. Why did I pick these two? These 2 grooves per inch are typically what we see or would like to see in the first stage of cracking, or in any cracking, I guess, for the first stage. And you have 3.5 grooves on the top side because it's that round bottom V we'd like to see up there. And typically with 3.5 grooves an inch, we get those beans accepted into the machine a little quicker, into the roll nip. And then of course we got to step that down, right? We want to split the beans into 4 to 8 pieces roughly. And the 5 grooves an inch does a good job of that. If you're somewhere in the world where you have small beans, maybe that's a dry growing season, maybe they're just small, you know, maybe not a very long growing season, what can happen is the beans get small, and we would typically see a 5 groove an inch on the top set of rolls and maybe a 7 grooves per inch on the bottom set of rolls. Works great, still gets the soybean split into 4 to 8 pieces. We also see good dehulling results from that after splitting those beans up a couple of times. Another good point here for the 3.5 groove versus a 5 groove is with less teeth per inch or less grooves per inch, you have a deeper cut. Okay, and that will also do a good job of evenly allowing those rolls to evenly wear, instead of just the top pair being like smooth flaking rolls, versus the top pair still have grooves on them. So if you've experienced your rolls on the top set being smooth and you didn't get all the work out of your bottom set, you can change your top pair to that 3.5 grooves an inch, and have better wear. Okay, tram and parallel. Tram basically means that your rolls are level all the way across. So these roll shafts here are going to be level. Okay, sometimes what we see out in the field is one shaft is a little bit higher than the other shaft. Okay, what you're going to see if that happens, one, you're going to have probably whole beans passing through on the sides, but you're also going to see a lot of uneven wear here. In the center of the roll, you'll see where the corrugations are completely smooth, they're worn down, and on the outsides, they're not making a very good contact, so that they're almost brand new looking. So if you guys see that, check your tram. Parallel is also very important to make sure that we have like particle size coming through the machine, or exiting the machine rather, and even roll wear. Parallel just means that the rolls are actually parallel. We don't want a larger gap on one side than the other side. Okay, so one thing you guys should always be checking as you're doing roll changes is, do you have your rolls parallel, and are they in tram? Okay, roll differential. This is just a difference in speed between the front and back roll. For hot dehulling, we need the highest shearing action in this machine because the bean is warm, okay, or hot. So we typically go with a 1.67 to 2-to-1 differential. Okay, that just means a fast roll is moving twice as fast as a slow roll. Okay. In warm dehulling, same thing, 1.67 to 1 typically. We don't usually see a 2-to-1 in warm dehulling. We don't need that much shearing action. So we just step that down a little bit. And then in cold dehulling, for you conventional guys, we don't need a lot of roll speed differential at all. 1.5 to 1. Okay, the bean is cold, it's very easy to crack. So 1.5 to 1 roll speed differential is the way to go for that. Keep in mind, if you're seeing a lot of dust, a lot of fines being generated in the cracking mill or in the first stage of dehulling, maybe your hull fats are going up. We can change your roll speed differential, and that could have an effect. Okay, so if you're warm dehulling and you have 1.67 to 1 differential, or a 2-to-1 differential, and you're seeing a lot of fines, we can step you down to 1.67. Okay, 1.5 to 1 for cold dehulling. That's the max that we like to do. It will generate fines. You're always going to generate fines when you're cold dehulling. It's just, you know, the nature of the beast, I guess. But we could step this down some if that's a big concern for you guys. Another thing, if you are in hot dehulling or warm dehulling and you're creating a lot of fines, look at your conditioning process. Make sure you're conditioning those beans all the way through, and that should lower the amount of fines that you produce as well. Another thing that we want to do to make sure that we keep this roll speed differential is checking our belt tensions. I would check this weekly if you guys have a problem with this. If you guys are snapping belts or you're not getting a good quality product out of your cracking mill, check your belt tension. Okay, we typically like these springs compressed between at 5 1/4 to 5 1/2 inches. On this little ruler here, you would see some numbers there, and we try to set this this spring tension to that 5 1/4, 5 1/2 typically. Okay. Also, when I'm walking through the facilities, I see a lot of broken belts. Okay. If you have a lot of broken belts, you know, that typically means something uncrushable came through. And these belts are the weak point here. That's by design. We want to break belts instead of breaking a roll shaft. So if you guys have belts that are constantly breaking, check your sheave wear, make sure you have clean beans coming through the equipment, and then also changing your belts frequently. I would recommend to change belts every time you do a roll change. Okay, moving off of cracking, we're going on to flaking mills here. When we're optimizing the flaking mills, again, we want proper feeding. That's going to be a reoccurring theme here, proper feeding. Even roll pressure, roll stops and pullbacks, cheek plates, scrapers, and aspiration. Okay, proper feeding. On our modular feeders here that you see on the flaking mill, we have an agitator lump breaker. a feeder roll as well. Okay, this lump breaker here is to break up any agglomerations that could have been made in the conditioner, especially for you guys that have the rotary conditioners where it's rotating back and forth. We do see some agglomerations coming out of those, and they get stuck up in the feed gate right here. So the agglomerations come through, they get broke up by this agitator shaft, and that should prevent a lot of blocking in your feed stream. Okay, we typically set our feed gate to 3/8 of an inch, about 9 to 10 millimeters. That's the gap between the feed gate here and the feeder roll. Okay, typically we set it to that, and then we make adjustments as we're going through. Like I said, with cracking, the feed curtain should go the full width of the machine, of the roll. So if you have a 32 by 84 inch flaker, it should be 84 inches wide. Okay. One thing you might have to do here is pull back one of your magnets to look in there to make sure that you're getting feed all the way to these corners on both sides. All right. We do have the feed roll is typically VFD capable, meaning you can slow down or speed up the speed of your roll. This is very good for fine tuning your flaker. We also have a rear seal back here on the feeder roll to prevent any material from falling off the back. If you guys open up this back door here and see soybeans going through, they're probably bypassing the roll. They're not getting processed, and you guys will be sending that off to extraction. So just make sure that this seal back here is about 10 thousandths off the roll. Okay, even roll pressure. Roll pressure should be within 50 psi of each other. So we don't want one cylinder more than 50 psi of the other cylinder. Here in this picture below, I show you the left and right roll cylinder pressures. That's a good indication for you guys to look and make sure that those are even. If they're not even, you're going to have uneven flake thicknesses, or you could have uneven roll wear. Sometimes when I'm going through the plant, I will notice this. They're within, they're 100 psi difference, or maybe even more than that. That's typically to correct the result of a taper on the roll. You can run that way for a small amount of time until you can get the machine down to grind rolls. But really, we want to make sure that we have even roll pressure so we continue our even roll wear. Roll pressures can vary on our flaking mills, anywhere from 400 to 1200 psi. The higher the temperature, the higher the moisture beans, the lower the amount of pressure you're going to have to use on your flaking mill. If you guys have dry beans that are not very hot coming into the flaking mill, you're probably going to be maxed out at 1200 psi. Again, the more pressure that you guys use, the higher the amp load you're going to have. Okay, roll stops and roll pullbacks. Okay, this is one of the most important things that we have on our flaking mills today. When I go out to the plants, the biggest issues that I see typically are rolls falling, or maybe a washboard on the roll, depending on what kind of rolls you have. This is going to allow you guys to help prevent some of that from happening. When we set roll stops, we want the rolls heated all the way through. Okay, we don't want the rolls cold, new startup, and we set the roll stops right away. What's going to happen as those rolls heat up, they're going to start to swell. Okay, so you might think that you have your rolls preventing from touching each other. Well, when in reality, as they grow, because they're getting higher in temperature, they do eventually touch. Okay, so we want the rolls heated all the way through. We want our operators making very good flakes, okay, at a good capacity that they're going to run at consistently, and get their desired flake thickness. Then turn this nut here. This is the roll stop nut. Okay, once your operators are making perfectly good flakes, the rolls are heated all the way through, we're going to turn this clockwise all the way in until it butts up against the cylinder. Okay, if we want to do roll pullbacks, we basically turn the roll stop all the way in, back it out 3 turns, clamp it down. Now that roll is allowed to free float. Okay, a big question I get, hey, if I set my roll stops, and my operator can't make the desired flake thickness, what do I need to do? So eventually what's going to happen is that the rolls are constantly wearing. It's not going to allow you to come in any further because you have roll stop set. Okay, so what's going to have to happen is you're going to have to turn your roll pressure off, back this nut out a couple of turns, go back, turn roll pressure back on, start feeding, flake, and then turn your roll stops back in. Okay, you probably have to do this once every 2 weeks, maybe a little bit longer, but your operators are definitely going to know it because they're going to increase their roll pressure and nothing's going to happen. Your flakes are not going to get any thinner. Okay, this will prevent roll-to-roll contact if you lose your feed curtain. If your feed is no longer coming through the feeder because of an agglomeration plugging up, or maybe just a lack of feed, the low level switch doesn't kick out, whatever, this will prevent those rolls from touching. I always recommend, especially new operators, new facilities that are just starting into the soybean crush industry, to set these roll stops from the get-go. Don't forget, if you have to shut down for a while and your rolls have the ability to cool down, we need to take these roll stops off, okay, turn them back out, allow your operator to bring the machine back online, make good flakes, heat the rolls all the way through, and then we can turn them back in again. Okay, the next thing on flakers, scrapers and cheek plates. We need these scrapers here to keep the rolls clean. If you have high moisture soybeans, what's going to happen is they're going to wrap around your roll. Okay, they're going to give you uneven flake thicknesses, uneven roll temperatures, and they're going to cause a lot of issues. I see scraper issues a lot out in the field, typically because they're hard to see. They're out of sight, they're out of mind. And what we want to do to make sure that we have a good clean roll is that your scraper blade here, shown bolted on the assembly, is the full width of the face of the roll. Okay, this is constantly touching the roll, so it is causing the roll to wear some. And if it's uneven, you're going to have uneven wear on your roll. Okay. Same here with the cheek plate. You see the cheek plate on the outside edge. Okay, this is what keeps the material from bypassing the rolls, from going around the roll ends. Okay, I get a lot of questions on these all the time from soybean facilities all across the world. We typically set these at 10,000ths of an inch off the roll. Okay, but what happens is guys will set these when the rolls are cold at 10,000ths of an inch. They'll heat the rolls up, and these rolls will swell into the cheek plate. So what we've done is we typically will set these at 15 to 20,000ths of an inch off the roll, allow those rolls to expand and seal up really good up against this cheek plate. We also make different sizes of cheek plates for different diameters of rolls. So if you have a 32-inch roll and it's wearing down to, let's say, 30 inches, you're probably going to have to change your cheek plates out a couple of times to make sure you have a good seal here. Okay, flaker aspiration. Anytime I'm out in the field, what I like to do is I like to open up the feeder door. Right away, open up the feeder door, and if I see any dust accumulating on the finger guards that prevent you from reaching down into the rolls, that's a pretty good indication that we don't have good aspiration. Typically for a 3284, we want to see about 3,000 CFM, okay? So what we typically do is we like to aspirate from the bottom of the takeaway conveyor, the flake conveyor. It goes off to extraction. We like to pull the air from the top of the machine all the way through to allow that material to get pulled through the machine, as well as dust. We don't want dust accumulating in the machine. So if we wanted to split this up for 3,000, we would have 3,000 CFM here in between the two, okay, to split up 1,500 and 1,500. And then we would have 1,500 CFM on the outside. Okay, that's how we get to 3,000 CFM per machine. Okay, you know, dust accumulating, not only does it unevenly wear rolls, it sticks to the cheek plates, it sticks to the scraper blades. What can happen there is we can eventually start an ember. Okay, that's the last thing that we want to do is send a smolder or an ember off to extraction. So good aspiration keeps the machine clean. It allows the operator to be able to look inside, make sure that he's seeing what he should be seeing, and that we don't have any issues with smolders or embers. Okay, moving on from flaking. These are the two machines here that we typically have set up for our meal grinding. The meal coming out of the DTDC comes through a Gladiator. This is just a big lump breaker, breaks up any lumps that you might have coming out of DT. And then we have a hammer mill grinding the meal. We could also have a roller mill there. In some places in the world, we do have roller mills there. But typically in the US, South America, and Europe, we have hammer mills here. Typically it's fit with a rotary feeder up top, so we can measure, again, it's volumetric, we can measure how much is going through each machine. Okay, so when we're gonna optimize our hammer mill, again, we want to have proper feeding. We want to be feeding all the way across the pocket feeder. Okay, we look at tip speed. Okay, tip speed is gonna help us get the meal broke up into the particle size that we need efficiently. We also have screens that we take in effect, hammers, and aspiration. Okay, tip speed. When we're talking about meal grinding, you know, we want to get this material in and out as fast as possible. We don't want that material sticking in the grinding chamber, wearing out hammers, making hammers rock, all that good stuff. So what we do typically when I'm sizing a hammer mill for meal grinding, I typically like to stay around this 44-inch diameter on the rotor. Okay, it might be a 30-inch wide by 44-inch machine. Okay, running at roughly 1,800 RPM on the motor gives us about 20,000 feet per minute hammer speed here. Okay, this does a very good job of hitting the meal, getting it classified to the certain size it needs to be. In the US, that's 90 to 95% less than 10 mesh screen or 2 millimeter for trading spec. South America, Europe, maybe it's a little bit more coarse, could be 4 millimeter. But this 44-inch machine does a really good job of getting us there. It's also going to create some fines, which will increase bulk density, which is what we see today is one of the most important things when grinding meal. And for bulk density, we're typically around that 39 to 40 pounds per cubic foot. Again, we can go up from there with more tip speed or smaller screen size. However, you will produce more fines. So just keep that in mind. Okay, hammer mill screens. Okay, replaced frequently. We want new screens in the machines to make sure that we are getting the meal to the size that it's supposed to be. You know, if you have a lot of holes in your screens, you're going to have larger particle sizes coming through. All right. We also want to change the rotor rotation, forward and reverse, so we can wear out both sides of the holes in the screens. Okay. We also want to make sure that we have the correct stagger. Okay. We want to make sure that there's no way that material doesn't see a hole. Okay. And then we also want to use the maximum open area for the screen that we can use in that machine to get the most throughput through it. Typically when we're grinding meal, I typically start people out at that 10/64/7-inch screen. That will certainly get you to that below 2 millimeter. And then if you need to be a little coarse, we can go up to a 12 or a 16/64 7-inch screen to allow the larger particle size. Screens are very, very easy to replace. Typically, you know, you're gonna change screens 2 to 4 times per hammer change. Okay, for hammers, we want to change rotation on the hammers as well. Wear out both corners. Okay, so here's your hammer up here. We want to wear out 1/3 of this corner and 1/3 of this corner here. Okay, we want to replace when the hard facing is gone. Okay, typically hammers that are contacting the material have hard facing on them. So as soon as you see that hard facing gone, we need to replace those hammers. Hole stretch or elongation, wear above the hard face indicates overfeeding. Okay, if we're overfeeding the machine, the material probably isn't exiting the screens. It's getting accumulating down below in the regrind chamber. So every time those hammers take a pass, they're going to plow through that meal. So when they're plowing through that meal, what you're going to do is you're going to see wear way above your hard facing. You're also going to see that hole elongate that the pin goes through. Okay, now that hammer can move. You should see vibration going up on your hammer mill when this happens. Okay, you need to replace those hammers. You need to maybe lower the amount of feed you're putting through it to keep this mill running at an optimal level. Okay. Also, if you have uneven wear on your hammers, okay, we probably have a feeding issue. Okay, if all your hammers are wore out on half the rotor, okay, that means it's seeing feed. They look brand new on the other side, they're not seeing any feed on that side. Okay, I also see airflow. If we have too much airflow in our takeaway, from aspiration, what can happen is as soon as that material drops through the HRF, it's going to pull it off to one side, allow it to come get hit through the screens, exit, and out the takeaway it goes. So if you guys are seeing uneven wear, check your feeding and check your airflow. Okay, back to our Gladiator. So we size these things for material coming in about 100 millimeters. I have seen material come in higher than or larger than 100 millimeters. You know, typically it does happen, but it's not a guarantee that we can keep the capacity if you're much larger than that. Material coming out is always going to be around that 10 millimeter mark, maybe even smaller. Okay, we don't want anything higher than 10 millimeter coming into the hammer mill. All right, you're going to get uneven wear on your machine, and you're probably going to create some rocking on those hammers, which is going to elongate that hole. We can do hot and wet meal from the DT, as well as a dried and cool meal from the DC. Okay, typically what we do is we see the dried and cool meal coming from the dryer cooler after extraction. Also, when we break up these agglomerations, the inside of these agglomerations are hot still, and they're very wet. Okay, we do not want hot and wet meal coming into the hammer mill. It's going to blind the screens. You'll eventually blow them out. You'll have to shut it down and perform some maintenance. Okay, now we're going to talk about hull grinding, hull processing. We typically use two machines here. One is a hammer mill. Okay, after the dehulling system, the loose hulls get fed through a hammer mill here. We typically have it set up with an HRF. You could have an ASF as well, which is an air separator feeder. This is very important if you guys have you know, a lot of foreign material coming in with your hulls. Okay, foreign material causes fires. The hull grinder is notorious for that if you have foreign material coming in. So what we do is we allow the air separator to blow the hulls into the grinding chamber and allow the heavy stuff to fall back and discharge away from the mill. We also have a pellet mill. Okay, so we want to increase bulk density on these hulls because they're very light. And one way we do that is through a pellet mill. Okay, pellet mill parameters are typically 3/16 of an inch to 1/4 of an inch, or 4 millimeter to 6 millimeter pellets. Product coming out of the conditioner, I get this question a lot out in the field. How hot should my product be, and how much moisture should I have? We always fit these conditioners with steam and water. Okay, we typically want to see the hulls at about the ground hulls at about 170 to 180 degrees before it discharges into the pellet mill. Okay, that typically means we need about 45 to 60 seconds of retention time here in the conditioner. Okay, this will allow the water to get mixed in. It'll allow the steam to heat the product, and with that water added coming in, we can usually get the hulls to 15 to 16% moisture. Okay, if you have very little moisture in your hulls, what you're going to see is your amp load is going to increase. Okay, same thing with your temperature. If your temperature isn't up this high, what you're going to see is that pellet mill now has to do more work to make a good pellet, and it's just going to increase your full load amps on your motor. Okay, die specs on a pellet mill. Again, 3/16 to a 1/4 inch hole. Usually we do an L over D of 6 to 1 or 10 to 1. I typically like to keep that 10 to 1 for hulls. Just makes a really good pellet. Your PDI is very good at that L over D. You have a countersink inlet on your die, and then depending on how narrow or wide your die is, you could have a straight relief or a staggered relief. Okay, this just allows for even wear on the die, allows for more even wear on the rollers as well. Okay, we have about 20 minutes left here. Is there any questions for the group?
Ian, I do not see any questions in the window. Do you see any questions in the chat window on your end?
I have some on the questions thing. Could you repeat the explanation about roll stops, adjustment, and flakers? Yes, I can. Let me go back here. Okay, so roll stops. If you do not want your rolls to touch on the roll ends or to touch anywhere in case of a lack of feed or a blip in the system, what you can do is after the rolls are heated all the way through, so typically our rolls are about 7 to 10 degrees within the bean temperature coming through. So if you're heating your beans up to 140 degrees Fahrenheit, your rolls are typically need to be about 130 degrees at full capacity. If you're below that, that's okay. That just means you're not at full capacity for that machine, which is okay. But it needs to be at a consistent roll temperature from what you guys are used to. So once the rolls are heated all the way through, you're making your desired flake thickness. You turn these roll stops all the way in until they butt up against the cylinder. Okay, that will prevent that roll from moving in any further if you have a lack of feed. Okay, pullbacks. It's pretty much the same thing, just one step further. You're going to counterclock or clockwise push this nut in all the way up against this cylinder. Okay, then you're going to back it off 2 to 3 turns. Okay, this will allow that roll to free float. Once you have that roll free floating and you lose your feed, that roll does have potential of hitting each other. The rolls do. So whichever one you want to use, they both work well. Roll stops or pullbacks, they're pretty similar in how you set them. Again, today with the new facilities going up, new operators every day walking into the door, it would be one of my flaking procedures to set these roll stops. It's just another safety feature for you to use so that you aren't contacting rolls. Do you recommend setting roll stops on both soybeans and rapeseed? Absolutely. Rapeseed especially, because the material is so small, canola is so small, your roll gap is not very big anyways. For canola though, we typically don't see this style of roll stop. You might see it on there, but we also have a fixated roll stop, which is basically a jack that sits in between the bearing blocks. The jacks are nice for rapeseed or canola just so that you can open or you can open up your gap or close your gap while running. I should reiterate this, that if you guys are going to try to take these roll stops off, you have to do it with your roll pressure off. Okay. Wow, we got a lot of questions coming in. Okay, would you repeat the explanation about tram and parallel? Okay. Okay, tram means that you have your roll shafts are even, okay, in the mill. We have a tram bolt that pushes on the bearing slide that the bearings ride on in these machines. If they're uneven, what's going to happen is you're not going to get your material processed all the way across the full face of the roll. Okay, so what you can do is you can put a level across your roll shafts here and make sure that they're even all the way across. Okay, for parallel, that just means you have an even gap all the way across your rolls. Okay, you don't want one side moved in farther than the other. That means you could be processing beans on one side while whole beans are falling through. So for consistent particle size coming out of the mill, we need to have rolls in tram as well in parallel. Do you recommend a shredder or a chipper before the dryer for the soybean husk for pelleting? Not quite sure what a shredder or a chipper is. We do hammer. We do put the loose hulls into a hammer mill to get them to a good particle size. I typically use an 8/64 of an inch screen, just because I want to do most of my work in my hammer mill and less in my pellet mill. It's much easier to change out hammers than it is dies and rolls. So I like to do a lot of work in my hammer mill, send those ground hulls to the pelleting and let those pellet. Okay, moving on here to the next question. 16 flaking mills, we have a problem with the edges of the roller mills break and come off. Why is this? Okay, if you have spalling on the rolls, okay, the question is why do we have spalling on the roll ends? When you're flaking, typically what happens is the inside of the rolls wear out faster than the outside rolls, right? It's just due to foreign material coming in, like sand or rocks or anything like that. And then typically we call it the roll ends are getting high, okay? It's not, it's just the inside is wearing faster. But if you have your roll ends are getting high and they're flaking, what's happening is you're concentrating, let's just say 1200 psi of roll pressure on a very thin amount of material of the roll. And instead of spreading that pressure all the way across the full face of an 84-inch roll, you're concentrating that now on a very thin piece of the roll. So when that happens, it creates more heat. I always recommend operators or maintenance or whoever is taking care of the flakers to take roll temps. Roll temps will tell you a lot of things. If you have high roll temps on the ends, okay, that means you're probably doing more work there. Okay, that's going to create work hardness, which will eventually make the roll brittle and then break. One other thing that's going to make that happen is if your rolls touch. Okay, if your rolls are higher on the outside than they are in the center and they're touching, the rolls are going to fall very, very quickly. Okay, setting the rear seal on the feeder. Okay, here's your rear seal. this is a slotted hole that this is mounted to. We always set this at 10,000ths of an inch, okay, off this roll. You do not want it touching the roll because it will amp out this motor. But 10,000ths of an inch off this roll evenly all the way across will prevent any soybeans from falling off the roll, or canola or rapeseed. Okay. Let's go to the next question here. Is it necessary to have aspiration systems to the crackers equipment as well? What are the benefits? So typically in cracking mills, you would have an aspirator down below it. Whether it's a Kais aspirator or a crown aspirator, that is pulling that dust through, that is allowing that material to fall through the cracking mill. So yes, it's very, very important to have aspiration on your cracking mills. It's typically, though, coming from a different machine. It's not, we typically don't see a separate air system for just the cracking mills. That's typically coming from the aspirator down below. Okay, when measuring for parallel and on the rolls, we typically set a 10,000ths gap on our cracking rolls. Okay, let me go back to that. We typically set a gap of 10,000ths all the way across here. And what we do is we take a 10,000ths feeler gauge, okay, and we just make sure that we have an even drag all the way across this roll to ensure that it's parallel. Also at CPM, we have the Smart Gap system, which measures the gap between the bearing blocks. This will tell you if your rolls are in parallel or out of parallel. So if you guys are interested in seeing that, reach out to your sales rep and they can give you some more information on Smart Gap. But how we do it mechanically is we just push the rolls in, okay? We make sure that the rolls are parallel all the way across by dragging the 10,000ths feeler gauge in between the rolls there. And if we do have one side out farther than the other, we disconnect the jack and we move one side in versus the other to get parallel. Okay, one thing I didn't mention to optimize flaking is roll-in grinding, and full face grinding. When you're roll-in grinding, you want to make sure that you're roll-in grinding about every 30 days. Could be even 50 to 60 days, depending on your process. Again, if you're pulling flake thickness once or twice a shift, you're going to see those flakes on the end start to get thin. As soon as they're starting to get thinner than they are in the center, it's time to do roll-in grinding. But if you didn't want to use your flake thickness to go through that, we typically recommend every 30 days touch upon the roll-ins. Full face grinding, we typically recommend that you full face grind once every year. If you keep up on your roll-ins, once a year is enough for full face grinding. If you guys don't keep up on your roll-ins, then you're probably gonna have to full face more than once a year. Especially if you have uneven feeding or foreign material coming through and unevenly wearing out the roll, you're probably gonna have to full face a lot. We have seen people go out and only full face once every 2 years. Now these guys are doing a very, very good job of roll-in grinding. They keep up on it. They're taking roll temperatures constantly. They're taking flake samples constantly. Just to ensure that their rolls are doing what they need them to do. What is the hardness of rolls, and what is the average life of the roll for flaking and pellet mill? Okay, so the flaking mill rolls, it's going to depend on what kind of roll you have. If you have a chilled iron roll, you're going to see anywhere from 50 Rockwell C all the way up to 56 Rockwell C, okay, very hard. If you have an indefinite chilled roll, typically they're going to be a little bit softer. They're more forgiving. They're going to be anywhere from that low 40s to mid 40 Rockwell C, 42 to 46 roughly Rockwell C on there. So they are softer. Again, a harder roll isn't going to wear as quickly, right? It's going to withstand all the wear from the beans, and you're not going to have to full face as quickly. However, chilled iron rolls will spall, and so you do need to keep up on those roll ends as they get higher up. For the pellet mill, it's just a normal chilled iron roll shell. They're fairly hard. I don't remember the actual Rockwell C on those, but I can get that to you. Can you go back to the conditions for hot, warm, and cold dehulling? Oh. Okay, we talked about roll differential speed with hot and warm dehulling. Okay, hot dehulling, you're typically seeing those beans anywhere from 180 to 170 degrees Fahrenheit. Because of that, we need a higher shearing action. Okay, warm dehulling, they're probably coming in around 150 degrees, maybe 140. And cold dehulling, they're just coming in at ambient, 75 degrees, maybe 70 degrees coming in typically. So we don't need as much of a shearing action here. We don't see the roll speed differential being that high. Again, if you have a very high roll speed differential and cold beans, or maybe even beans that aren't heated all the way through, you are going to create more fines. Okay, so one thing I always tell guys to look at your hull fats. If your hull fats are really high, okay, we're probably creating too much dust in the cracking mill. All right, if your fiber is high in your meal, we're probably not cracking enough, or we're not doing a good job of dehulling, blowing those hulls over to the hull grinder. Okay, so those are two things that I always look at when I'm talking about cracking mills: is what's meal fiber like and what are hull fats like. That will tell me how to adjust my cracking mills. Okay, just moving here through some more questions. Okay, what's the difference between an HRF and INF feeder? Well, the INF feeder is the infusion feeder on the pellet mill. Okay, this is your infusion feeder for the pellet mill. This is your HRF feeder for the hull grinder or the meal grinder. Yeah, I didn't talk about this much, but same exact thing for the meal grinding we want to do for hull grinding. We want to make sure we have an even feed all the way across. Okay, we want to make sure that we're getting the right amount of capacity through our feeder that's suitable for our hammer mill. In hulls are very abrasive. We want to make sure we're changing out our screens often, as well as our hammers. Also changing rotation to wear out both sides of the hammer and the screen. But that's the difference. Here's the infusion feeder. Here's the HRF. What's the acceptable range of fine generation? Great question. I don't have the answer to this. We want to create as few fines as possible. Obviously, we don't want a lot of high hull fats. We don't want a lot of fines moving through the rest of the system because they unevenly wear out rolls, and they also plug extractors. So we want to make sure that we don't create a lot of fines. However, if you're in an area where you have very dry beans, you're going to create fines. You're going to create fines regardless, but you will create more fines with the drier beans that you have. I get a lot of questions about, hey, how hot should I have my beans coming out of my conditioner if my beans are dry? Well, the hotter the better, we say. We want those beans hot. Now, we don't want you to continue to dry those dry beans down even further. So what we would want you to do is lower the amount of aspiration you have in your conditioner. Okay, we don't want to remove more moisture. We want to keep that moisture in there so we get better results out of our flaking mills. Okay, we already answered that question. Okay, which is the best size of hull for pelleting? Okay, like I mentioned before, out of my hull grinder, well, in my hull grinder, I usually use 8/64 7-inch screens, just because I want to have my hulls ground far enough to where my pellet mill doesn't have to do any grinding in the die, in between the die and rollers. So do your work in your hull grinder. So all you have to do is get the ground hulls into the pelleting chamber, let those rolls press it through the die, and exit. If we grind too fine in the hull grinder, it's going to make, fines are hard to handle. It could create some issues here in the feeder as well in the conditioner. And again, I want to say this again. Your conditioner, once you start feed into here, it should take about 45 to 60 seconds of retention time in this conditioner before it drops to the pellet mill. A lot of times I see it in there for maybe 20 to 30 seconds. Okay, you're not getting enough heat in your hulls. You're also probably not getting enough water mixture in with your hulls to lower the amount of full load amps that you're seeing on your pellet mill. So if your pellet mill is running pretty rough, and even though you have a new die and new rolls inside, okay, we got to make sure that those hulls are conditioned properly. Okay, guys, I think that's all the questions that we have for today. I don't want to take too much of your time. Thank you for joining our webinar today. If you guys have more questions, feel free to reach out to us. Reach out to your local sales rep, reach out to us here in Waterloo, and we'll try to get any more questions that you guys have answered.
Yeah, I don't think we shared Ian's email address, but it's ian.hall@cpm.net. So pretty easy email address, ian.hall@cpm.net. Please reach out if you have suggestions for upcoming webinars. We'd love to hear from the customers on what areas you're being challenged and what areas are you seeing as important. So please feel free. Any suggestion is a good one. We very much appreciate it. And thank you very much. With that, we will sign off. Thanks for your time.